Hello again. We are moving on in our unit of trigonometry, and we're going to talk about three-dimensional problem solving. This is lesson 9.4, so let's get started. I have an example here. It's just a straightforward rectangular prism. It's got dimensions 15 by 35 by 20, and I want to know what is the measure of the angle between segment AB and segment BC. So let's draw those to see where they are, and I can kind of see where the right triangles would be. I'm going to have to figure out what AB is first and then figure out what BC is second. So let's look at AB. If I look at that orange triangle there, it is a right triangle, even though it doesn't look like it two-dimensionally, but it is a right triangle with legs 15 and 20, and I want to know what the hypotenuse is. So using Pythagorean theorem, 15 squared plus 20 squared is AB squared, and that makes AB equal to 25. Now if I turn my attention over to this magenta triangle over here, it's also a right triangle. It's got legs of length 25, which I just figured out, and 35, which is that edge that runs along the top, and I want the hypotenuse. That's going to be BC. So Pythagorean theorem again, 25 squared plus 35 squared equals BC squared, so that's going to be about 43.0116. All right. So now I have two sides of a right triangle. I just need to figure out which angle I'm talking about. So the angle that I'm talking about is the one between those two red line segments, AB and BC. So I labeled that theta, and I'm going to use the sides 25 and 43.0116. 25 would be the adjacent, and 43.0116 would be the hypotenuse. So I'm going to use cosine. The cosine of theta would then equal 25 over 43.0116. Now since I want to know the angle, I have to use an inverse. So theta will equal the inverse cosine of 25 over 43.0116. And that would be about 54.5 degrees. All right, now I had all three sides of the triangle, so I could have used the 35 as the opposite instead. So I could have used sine, cosine, or tangent to figure that out. Now, what is a projection? That's the next definition we need to learn. It's basically a line segment that would be the shadow it would create on the base or the bottom plane if light was shining on it directly from above. So looking at where AB is and looking at where BC is, what would the projections of those two lengths be? Well, if a light is shining down on the red segment, it would create the blue segment, BD, and if a light was shining down on the orange segment, it would create the purple segment, BE. Okay? So let's figure out the angle between a segment and a plane. Well, that's just the same as the angle between the segment and the projection onto that plane. Okay, so I basically need to figure out the segment or the area, the angle between BC and BE. Okay, so let's look at this example right here. It's a 5 by 6 by 12. So I need to figure out the angle between BC and that bottom plane BDEF. First I draw the projection from B to E, and it's going to be the hypotenuse of BEF. Okay, and so Pythagorean theorem again gives me that BE is equal to 13 meters. Okay, so now looking at the brown triangle, BC is the hypotenuse of BEC, that triangle. So using Pythagorean theorem again, I get that BC is equal to about 14.318. So using the purple side and the red side, I want to know the angle between those. Okay, so I'm calling that theta. If that's theta, then 13 is the adjacent and 14.3 is the hypotenuse. Okay, so the cosine, that's what I'm going to use. That's going to be the adjacent of 13 over the hypotenuse of 14.318. I'm solving for an angle, so I need an inverse. Theta is going to equal the inverse cosine of 13 over 14.318, which is about 24.8 degrees. Now again, I could have used the length of 6 and used sine or tangent instead. So once I have more than enough information, I have a lot of choices as to which lengths I'm going to use, but I should always get the same answer no matter which way I choose. So that's it for three-dimensional problem solving. If you have any questions, please let me know, and I will see you tomorrow.